Hey everybody, I wanted to go over some sample problems to help you study for the test and try to get some of the main concepts down. I don't want to be that guy, but I'm going to have to be. There's some things that you're just going to need to know how to do in order to be successful on this test, and so that's what this problem is right now. So if we look at here, let's see, we're going to start with question 15.5. Okay, if I can get it. Yeah, so 15.15, and you can go in your copy of the book and look up. There's answers in the back of the book, but I'm going to go over how to write equilibrium expressions. Now they want, in this case, Kc, so this will be good. Okay, so let's spend a little bit of time writing equilibrium expressions. So this is 3NO is in equilibrium with N2O plus NO2. Okay, so it's 15.15A, the reaction was NO. 3NO is in equilibrium with, let's just double check that we have it right, N2O plus NO2, and they're all gases. Okay, so this is going to be plus N2O plus NO2. This is a gas, this is a gas, and this is a gas. Okay, so if we're going to write the equilibrium expression, Kc, remember equilibrium expressions are written pretty straightforwardly. It's products over the reactants, and so with products over the reactants, we do the concentration of, brackets means concentration of, N2O times the concentration of NO2 all over the concentration of NO, and that's going to be cubed because this coefficient is this power right here. Okay, so that's part A. Now for B, let's take a look at what B is. Okay, so this is methane, CH4 plus H2S gives us carbon disulfide plus hydrogen gas. So this reaction is methane gas plus H2S is in equilibrium with carbon disulfide plus H2. Now I'm just going to look at the question here. It's gas, 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 and it's 2 and 4. Okay, so this is 2 and this is 4. Okay, all of these are gases. Great. So now when we do this, again, it's products over the reactants. So Kc equals the products, concentration of CS2 times the concentration of H2 to the fourth, all over the concentration of CH4 times the concentration of H2S, and all of that is squared. Again, keeping in mind that these coefficients become the powers here, okay? And so if there's no coefficient, you can assume that it's 1, and then when there's no power, we assume that it's 1 too. Okay, so that's B. Now let's go down to C. Okay, so C. Okay, same thing. Let's see. Okay, so it's nickel tetracarbonyl, nickel plus carbon monoxide. Okay, so let's do this. Now we're getting into some other problems. So this is Ni, and then it's tetracarbonyl is in equilibrium with Ni plus 4CO. And let's look at the states. Gas, solid, gas. Okay, so this is a gas. Nickel is a solid. Carbon monoxide is a gas. Okay, so now this shows a slightly different way to do these sorts of problems. Okay, or not different way, but a different thing. And a different take is because nickel is a solid. So this is called a heterogeneous equilibrium. That's a good vocabulary word to write. Okay, so now when we do this, and it's heterogeneous, it's still products over the reactants, but we only worry about gases in aqueous solutions. So it's the concentration of CO, and that's to the fourth over the concentration of NiCO4, and that's to the first. Okay, notice because this guy is a solid, we're not including him, and because that's a 4, that's the power there. Okay, so now part D. Okay, HF ionizes. Okay, so we have HF is in equilibrium with H plus F minus, and this, let's just double check. So it's aqueous, 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 everything's aqueous. Okay, so we go aqueous, aqueous, aqueous. Just to let you know, my AQs are horrible. It's always the way it is. And so when we do the Kc, that equals the concentration of the products, H plus, okay, times the concentration of the other product, all over HF. There's no coefficients, and that's the way it is because there's it's all aqueous. Okay, so now for E, and again, if you want to work on these on your own, you can try it yourself, and then you have the answer, and you have me working through the answer. Okay, so this is a redox reaction of silver reacting with zinc ion. Okay, so that's cool. So for part E, it's silver, and it's 2 silver plus the zinc ion, that's solid, plus the zinc ion, and that's aqueous, is in equilibrium with 2 of the silver ions plus a zinc solid. And again, this is a heterogeneous equilibrium, so we're not even going to worry about these two things in terms of writing our equilibrium expression. And so we do Kc is in equilibrium, or equals, sorry, Ag2 plus, or sorry, Ag1 plus squared all over the concentration of zinc 2 plus. Okay, and again, this, that is that. Okay, so now, excuse me, so now F. So we have water decomposes, okay, or ionizes. Okay, so for F, let me make this black here. So it's H2O is in equilibrium with H plus plus OH minus. Now this was a liquid, this was an ion, and this was aqueous, an ion. So when we do this, Kc equals products, concentration of H plus times the concentration of OH minus, and this is a liquid, heterogeneous. We don't write that as part of our equilibrium constant expression. Okay, Kc is products over the reactants, and we only use aqueous solutions and gases. So now for G, the last one, G is, let's see, 2H2O is in equilibrium with 2H plus 2O2 minus, okay? Okay, so this is going to be 2H2O liquid is in equilibrium with 2H plus aqueous plus 2OH minus aqueous. Okay, and so now Kc equals concentration of H plus squared times the concentration of OH minus squared. And just to reiterate, this is a liquid, so that doesn't get written in our equilibrium expression. And again, these powers are the powers that we raise this to. Okay, now this is going to speak to a neat relationship between this guy and this guy, because what's the difference between the reactions? This reaction and this reaction are just multiplied by 2. This reaction is twice this reaction. Okay, and so notice that that just squares both parts. Okay, so but that'll be in a little bit. So that is question 1515, and I hope you can write equilibrium constants at this point.